Hey guys, welcome back. Houston Math Prep here. In this video, we're going to take a look at how to calculate the confidence interval for a mean with a known sigma, or a known population standard deviation. So in general, we know that confidence intervals are calculated by taking a point estimate and adding and subtracting the margin of error. So for an interval around a mean, our point estimate is going to be our sample mean, or x bar, and the way that we're going to calculate our e, or our margin of error, is going to be by taking z critical, and z critical is going to be the z-score that corresponds with a particular level of confidence. We'll come back to that in just a second. And multiplying that by the standard error for our distribution of sample means. Now, you might remember from our video on central limit theorem that standard error is calculated by taking the standard deviation of the population, or sigma, and dividing by the square root of the sample size, or the square root of n. So another way of looking at that formula is z critical times sigma divided by the square root of n. So sigma and n will just be given in the problem, but z critical will be something that you either need to just know or be able to find out based upon your level of confidence. So here are some common levels of confidence: 80%, 90%, 95, and 99, and their corresponding critical z values. Now, these four, I would highly recommend that you memorize. You're going to use them very frequently, and it would be much easier on you if you just kind of know those. But let's in general talk about how those are calculated. So in general, we are creating an interval around our sample mean x bar. So when we're talking about z here, we are in fact talking about a z-score. So if we think about taking a particular confidence level and centering that around the mean. So let's say we want to be, let's look at 90% confident. So if we want our confidence level to be 90%, then we want to extend to a z-score below and above the mean so that 90% of the area will be here in the center. So that would leave 1 minus our confidence level, or 1 minus 0.9, out in the wings. So what we could do is we could take 1 minus our confidence level and divide it in half. That would be how much is in this lower wing and how much is in this upper wing. So if I know how much is in this lower wing right here, I can use inverse normal to find the z-score that would go with that area below in that wing. So that's what these z-scores are, and we just use the positive version of them. So for 90% confidence, you would find that the z-critical, or the z-score that landed right there, would be about 1.64. So if you've got not one of these four confidence levels, just use inverse normal to find your z-critical. But here are four very common ones that we'll work with frequently. So let's look at an example. Let's say that 100 students' math SAT scores are randomly selected and a mean of 600 is found. So that's our x bar, right? That's our sample mean. It is known that sigma from this population is 50. So that is our population standard deviation. We want to find a 99% confidence interval and interpret it. So this is our confidence level, or our C. So remember that our confidence interval is going to be calculated by taking our point estimate of x bar and adding or subtracting from that our margin of error, which will be our z critical times our sigma divided by our square root of n. Our n is going to be our number in the sample. So let's get working on our margin of error first. So our margin of error will be our Z critical. 99% confidence interval means we're going to use the Z critical for 99%, which from the previous screen or using inverse normal is 2.58. We're going to then multiply that by our standard deviation for our population, which is 50, divided by the square root of our sample size, which in this case is 100. So using your calculator, doing that calculation, 2.58 times 50 divided by the square root of 100 gets me a value of 12.9. So my margin of error, or my value that I'm going to add and subtract from my sample mean, is 12.9. So now, to get my confidence interval, I'm going to take my point estimate of 600 for my sample mean, and I'm going to add and subtract 12.9. So 600 minus 12.9 gives me 587.1, and 600 plus 12.9 gives me 612.9. Now remember, in our confidence interval intro video, we talked about that when we report a confidence interval, it needs to have 3 components. It needs to include the interval, it needs to include our confidence level, and it needs to include the context of the problem. So when we go to report this confidence interval, we would write the statement: we are 99% confident, so there's our confidence level being reported, that the true mean of SAT math scores, so there's our context, what is it we're talking about, is between, and then we'll list our interval, 587.1 and 612.9. So now our report of our confidence interval has all 3 items. It has the interval, it has the confidence level, and it has the context of the problem. All right, guys, that does it for this video on confidence intervals for means with a known standard deviation. Catch you in the next one.